been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Geometry 11.3. We're going to look at perimeter and area of similar figures. So here are two equilateral triangles. All equilateral triangles are similar because all equilateral triangles have three 60-degree angles. And so we know these triangles are similar because they're equilateral. So let's just remember what scale factor is. Scale factor is the ratio of the corresponding sides. So the scale factor here will be 4 over 10, which is the same as 2 over 5. And that's looking at the small to the big. And so I could look at it the other way. I just kind of have to pay attention to what I'm doing here. So the scale factor is 2 to 5. So let's think about the perimeter. The perimeter of triangle ABC is 4 times 3, which is 12. And the perimeter of triangle DEF is 10 times 3, which is 30. So let's look at the relationship there. So the ratio of the perimeter is 12 over 30, keeping it in the same way we did the scale factor, small to big. So if I simplify 12 over 30, I can divide both of these by 3, which leaves me with 4 over 10. And then I can divide that by 2 to get 2 over 5. So what do you notice? You should notice that the ratio of the perimeter is the same as the scale factor, which will always be true. So the ratio of the perimeter of similar figures will be equal to the scale factor. And the real reason for that is because perimeter is one-dimensional. Okay, so we're just adding things up. It's one-dimensional. So now we need to transition to area. And if you remember, the altitude of a triangle is its height, and the altitude of an equilateral triangle is also the perpendicular bisector. So what this means is I can actually find the altitude in this triangle. If AD is the perpendicular bisector, then these are both 2. And so I have this small right triangle here where this is 2, the hypotenuse is 4, and I'm solving for x. So x is going to be equal to, so x squared plus 2 squared equals 4 squared. So x squared plus 4 equals 16, x squared equals 12, and so we have to take the square root of that. So x is equal to plus or minus, square root of 12 is the same as 2 square root of 3, just simplifying the radical. So we would obviously want the positive answer to that because we're looking at distance. So I'm going to go ahead and redraw this triangle down here and show that that is the height. All right, so here we have the same pictures drawn again. So now we're going to look at the area of these triangles. So the area of triangle ABC is equal to base times height divided by 2. Now, the base of this triangle is 4, not just 2, because we're looking at the large triangle ABC. So 4 times 2 square root of 3 over 2, which 4 over 2 is 2, so it's actually 2 times 2 square root of 3, which is 4 square root of 3. That is the area of that triangle. When we look at the area of triangle DEF, it is going to be, well, we need to find the height of this first. So I'll call this h. So h squared plus 5 squared equals 10 squared. H squared plus 25 equals 100. And so h squared equals 75. So h is the square root of 75, which is 5 square root of 3. So the height is 5 square root of 3. So the area is going to be 10 times 5 square root of 3 over 2, which is the same as 5 times 5 square root of 3, which is the same as 25 square root of 3. So now we need to compare these, and we're going to do it again in the same way, small to big. So we're going to do 4 square root of 3 over 25 square root of 3. Now, this can probably be a little bit tricky, but we are going to figure it out. So what I want you to think about is, I want you to notice that square root of 3 over square root of 3 is 1. So that would this would actually simplify to 4 over 25. And I want you to think about how that relates to the scale factor, which was 2/5. Think about how 4/25 relates to 2/5. Well, it turns out that 2/5 squared is 4/25. 2 squared is 4, 5 squared is 25. So what this means is that the ratio of the areas will be equal to the scale factor squared. So the ratio of the areas in similar figures will be equal to the scale factor squared. So if I know the scale factor, but I don't necessarily know any of the side lengths, or I don't know enough information to find the area, I could still figure out what the ratio of the areas was going to be. Or if I knew one area, I could find the other just by knowing the scale factor. We'll look at some examples in class.
I've been waiting way too long.